While we're playing with the Sunmoon and talking about sense wires, I decided to do another experiment here to show you how the sense pins work. So right now, since the sense pins are only on the 24 pin connector, I've only have a load on the 24 pin connector, and it's a 2 amp load. That's for the 12 volt. And as you can see here, the multimeter says we have 12.05 volts, and at the Sunmoon we have 12.01 volts. So we have a drop of 0.04047 because of the cable. So if we take this current and we're going to jack it up in real time, I want you to see what the voltage at the power supply does. So to recap here, I'm going to increase the load on the 24 pin. And what should happen is the sense wire will see that the voltage will drop, and then the power supply will compensate by increasing the voltage at the power supply. Okay, so here we go. So we're at 12.01 volts here, 12.05 here, 2 amp load, and watch what happens as I increase the load. Up to 12.11 with a 9.37 load, and keep going. How high does it go? 12.14. See, that's what the sense wire does. Because on the chroma, I was going to say chroma, on the Sunmoon side, our voltage has dropped all the way down to 11.99. And the power supply sees that through the sense wire and is compensating the voltage at the power supply. So now the power supply voltage output is 12.14, but because of the resistance created by the greater load through the cable, it caused the voltage to drop to 11.99. So let's find a happy medium. I'm going to bring it back down. Okay. I'm going to make sure my multimeter doesn't fall asleep. Bring it back down. 12.14 still, 12.13. There we go. Let's stop at 7 amps. So 12.10. Put the voltage at the load tester. It's up to 12.01. So hopefully that helps you better understand what the sense pins do in a power supply.